Welcome back to the Art of Math. Today we're going to go over basically everything you guys might need to know about inverses of a function. So the what, the how, and key properties. So let's start with the what. What is an inverse? So the inverse of a function, the way I like to think about it, is that it undoes or reverses the original function. So for example, let's call the original function f of x. The inverse is frequently notated as f inverse of x, so that -1 is the way we're going to write it. Now, here's a quick note. So if you've seen exponents, you might be thinking, well, that -1 means like 1 over. That has nothing to do with negative exponents. So this is just sloppy notation, and mathematicians use it anyway, but just keep in mind this is not a negative exponent. That's function notation. All right, so we will abbreviate f inverse of x as our inverse function. All right, so let's try to understand this at a basic level. Let's say we have y equals f of x. That's our original function. Now, I like to think of functions as factories. So you have inputs and outputs. So in this case, x is your input. You put it into your function or your factory, and it produces a y. This is your output. So let's take a sort of a real world example. You have leather and you want to make shoes. So you have a shoe factory. So you put in leather, that's your x, and your factory produces shoes. That's your original f of x function. Now, what is the inverse? The inverse would be the reverse of that. So you put in shoes and somehow you want to get leather. So now your x is the shoes and your y is the leather. So hopefully that makes sense. So it's really, literally doing the reverse. So I'm just going to jump down a little bit over here. So if you look at this line over here, so if you put in leather into your factory, the original factory produces shoes. If this is your inverse factory, it's going to take those shoes and produce leather. So if you run your input through your factory and then the inverse factory, you're going to get back what you put in, which is the leather. All right, so I want you guys to focus on two key properties as well as two ways of finding the inverse. So that's going to be the rest of the video. So the first key property will be f of f inverse of x is just x. Now that's what we've just seen. So let's see if we can understand this. If we put in leather, that's our input, that's our x, and we run it through our inverse. So in this case, the way I have it here, we're actually going backwards, but it doesn't matter. So if I start with leather and I run it through my inverse factory, the inverse factory is going backwards, so we're starting with shoes. So if I start with shoes and I go to the inverse factory, I produce leather. Now, if I put leather into my original factory, I produce shoes. So we started with shoes, we ended with shoes. This is the second formulation here, is just saying no matter which order we take it, whether it's f of f inverse or f inverse of f, we still get the input. So actually this second formulation here is what I have in this example. So if we put in x into f, that means we're putting leather into our factory. Our factory produces shoes. Now what is the inverse? What is the reverse of doing that? Now we're going to take our shoes and produce the leather. So in either case, the point is if you apply the function to its inverse, you get the input. So basically, you can think of these as like canceling each other out, the f and the f inverse. So that's a super key property. Let's see if we can understand this visually. So visually, let's say this is our function. I've just drawn a random curve over here, and let's focus on this point 10, 3. This is our y equals f of x curve. Now, the inverse means instead of when I plug in 10, I get 3, when I plug in 3, I want to get 10. So I want to get the reverse thing. So that means this point is now going to be that point because it's doing the opposite thing. So originally I plugged in my 10 to get my leather, to get my shoes. But now when I plug in my shoes, I want to get leather. So when I plug in 3, I want to get 10. So that's why this point now becomes that point. Or more generally, any point A comma B would become B comma A. So, and using that idea, we get the second key property. And this really stems from number one. So if you want to find the inverse of x, you can just reflect the original function across y equals x. As you can see in this diagram, this point goes to that point. Every point basically goes to the point that's symmetrically across this y equals x line. So if that doesn't quite make sense, just take a look at this diagram and just focus on a specific point, like this point, and see where it would go. This point will go here, that point will go there, all right, and so forth. Now, if you want to prove sort of officially that this would be the center line, you can just take these 2 points A, B, and BA, and then you could find the midpoint. So for example, for these points, the midpoint would be right here, and then you can calculate the slope. I won't do this in this video, but this is how you can get a deeper understanding. You can take the slope between these 2 points, which should be a line with slope -1, and the perpendicular slope would have a slope of +1. And how do you know that? That's just the property of slopes of lines. It's 1 over, basically it's the negative reciprocal. So 1 over -1 is just 1 over -1 is +1. So that's why the perpendicular line to this would be this y equals x line. So if you guys are interested, if I lost you guys there, don't worry about that tidbit. That's for people that want to get a little more rigorous and prove why it's this y equals x line beyond this intuitive visual understanding. All right, so again, the key property is applying the function to the inverse, or the inverse to the function just gives you back the thing you plugged in the first place. So the f's and f inverses drop out. All right, so those are key properties. We're going to use them to actually solve problems and find the inverses. So first, a high-level overview. So there's going to be 2 common methods. One will be the algebraic version, and one will be graphically. So the first one, if you're given a function y equals f of x and you want to find the inverse, all you have to do is 2 steps. Swap your x and y. So now where that y was, we put an x. Where that x was, we put a y. Now once you have this one, we are going to resolve this for y. So once you solve this for y, what you will get is this inverse function. We're going to see an example of that, but let me show you why this is correct. So why is this true? If you go back to this line, we're going to do the same procedure to both sides, which is, let's take, if you look at this line, the inverse of both sides. So the inverse of the left side is just f inverse of x, and the inverse of that side is f inverse of f of y. Now, using our key property on the left, remember that the inverse of the function just gives you back the input. So these are gone, and you're just left with this y, and the left side stays the left side. So what we found is if you do this procedure, you get this inverse function. Maybe you didn't follow that, so I encourage you to look at this example we're about to do and then see if this makes a little more sense. So let's take the example of y equals 2x plus 4. So that's a line, and I've drawn it over here. So it's pretty steep. It's a slope of 2, y-intercept of +4. And how would you find the inverse according to that procedure? Well, you swap your x and y, which I've done here. So now you have x equals 2y plus 4. And we're going to resolve for y. So move the 4 over, so 2y is x minus 4, divide by 2, y equals x over 2 minus 2. So now the slope is a half, and the y-intercept is -2. And that line is over here, so it's crossing on the negative spot here, and it's a little more shallow. It's not going up as steeply. So hopefully this looks intuitively correct, and you can check this using the second method. So that's why I said it's a graphical method. If you look at this line, the symmetric version of it across this mirror image of y equals x is that line. So my diagram is not perfect, but hopefully you get this idea. So the short of it is this. If you have a really crazy question and no numbers, but just some diagram, then you want to use method 2, where you just reflect visually. If you have actual numbers, such as in this example, and you want to get precise numbers, then you want to use method 1, where you actually swap them and solve. So that's why I said these are the 2 basic methods you'll be using. So that's pretty much all I wanted to cover, but there's one last important note. So an inverse may not be a function. So for example, we discussed how if you swap your letters and you solve it, you will find the inverse. So let's take a look at review what functions are. So what do functions do? We have some sort of input, that's your x, and these are different arrows. So you might have many inputs and they all map to a y. So let's have this make sense. So consider the question, what color is the sky? Blue, right? So let's say that's your f of x. You asked a question, so you gave it an input, and you want an answer. So in this case, your y is your answer, which is blue. However, are there other questions that could have yielded blue? Yeah, you could have said, what color is the marker that I used here? Blue. What color are my sneakers? Blue. So in other words, all these arrows represent, there are many questions that might yield that answer. Now, that means if we try to go in the reverse direction and saying, sort of like a Jeopardy thing where the answer to what question is blue, there's not a unique answer. There's many questions that get you blue. So, and if we look at this diagram, once we reflect this, remember a function must pass the vertical line test. So this original function does, because everywhere where you put a vertical line, it doesn't hit more than 1 point. But when you do this, depending on the exact function I've chosen, this could be in danger of failing the vertical line test. So like that could be a vertical, almost a vertical line over here. So why does that happen again? Because just because you can go many inputs map to the same output, in the reverse direction, the answer may not be unique. So if I said blue and I said, what question gave me that? You don't necessarily know. So what's a math example? So let's say we have y equals x squared. That's a perfectly good function. That's our parabola. So it passes the vertical line test everywhere. However, if we try to swap our x's and y's, we get x equals y squared. So now we're solving for the inverse. Take the square root, but remember we have to take the plus or minus square root to find all the solutions. And this illustrates the problem. So the inverse would actually look like these are the two parts of the inverse, so that's that plus or minus, and this fails the vertical line test. So because there's two answers, the square root of x and negative square root of x will get you y if you undo this parabola function. So that's why the original was a function. This is an example of that, and the inverse is not a function. It's still an inverse. We found some equation, but there's more than one answer. So that's just a quick note. Depending on the original, you may not get something that's a function legally at the end. All right, hopefully that was helpful. I'll see you guys in the next video.